We're going to be looking at electron configuration, which is where electrons are located within the atom, but remember these are highly probable locations. I will fill that out more a little bit later, okay? We're going to use these things called quantum numbers. Turns out there are 4 quantum numbers. You don't have to write down there's 4 quantum numbers. I'm going to tell you what they are and what they mean and what we can get from those. But anyway, it's kind of like an address. So when you know all 4 quantum numbers, you know where an electron is. If you know know less than 4, you do not have as much detail as to where the electron is. It could be in a different. What I mean by that. So what's the address of the school? Does anybody actually happen to know? 289 Euclid Avenue, Delaware, Ohio. I got 4 parts of the address, right? Would you agree? 289 Euclid Avenue, Delaware, Ohio. Well, so if you only know, like, say, 1 or 2 of those quantum numbers, you might know that it lives at 289, Ohio. There's probably a lot of 289s in Ohio, wouldn't you agree? Right. So we know it's in Ohio. It's not California, but still doesn't give us much information, right? Or we might know that it's in Delaware.
Which Delaware?
Ohio. Well, yeah, Delaware. There's more than one Delaware.
Delaware State.
Well, I get that. Do you think there's more than one Delaware city of Delaware? I would imagine there would be. Oh, by the way, you guys happen to know the name of a city that's the most used? It's not. It's near here. No.
I don't know. I'm just.
Nobody has a Cincinnati except us. What's that? It is Marion.
Oh, I was just trying to say.
Anyway, moving on. The first quantum number is called the. You guys okay if I just go QN?
Sure.
For quantum number? Of course, we're going to be writing it a lot. Okay. First, or the principal quantum number, we're going to use the abbreviation N to represent that. You guys are already familiar with that. N equals 1, N equals 2, N equals 3, the energy level numbers. Okay? This is the one and only thing that you've known so far. The energy level. This is it. Okay? Let me see. Has the values 1, 2, 3 through infinity. And this is actually kind of a true statement. An electron for an atom could still be deemed that atom's electron, and it could be anywhere in the universe. Now, what's the probability of finding a hydrogen electron for this little hydrogen atom right there out by Jupiter? Not very probable, okay? So what we have to do is we have to come up with a way of saying, okay, where can we expect to find the electron? And it was arbitrarily determined the value was 90% of the time. Where can we find an electron 90% of the time? And that gets us down into the size of the atomic scale that we're looking at. Okay? It could be anywhere, but 90% of the time it's going to be in this highly probable region. All right, so anyway, we can have 1, 2, 3, 4, 5, 6. Let me see, what else do I want to know? I should actually have my notes out as I do this so I can remind myself of some things. Give me a second. They may or may not exist anymore. Hey, look at that. Got him. That's amazing. Well, I guess I think we already understand this, but I'm going to go ahead and say it anyway. I'm going to go ahead and do the arc diagram thing on here again. You guys can do this if you want to. Okay, so now, and oh, I know. I knew I forgot something. It is. Remember, I already used a ladder analogy earlier, I believe, when we were talking about energy being quantized. Okay. In fact, you're going. What I'm going to tell you is, if you're going to go ahead and do this, and I would highly recommend that you do, I would fill up most of, probably a third of the width, and I don't know, half of the length of the paper. You can write your notes along the side. No, that's good. That's not bad. Yes. However, I'll show you this one. That one's not bad. That one's not bad.
Pretty big, right?
Can you see it?
I can't draw straight. 34 and a half.
Half a ladder? All right, so anyway, and if this, where do you put a ladder if you're going to use it? It's a really easy answer. It's not that hard of an answer. Where are you going to set the ladder? On the ground? Which in an atomic sense represents the nucleus, okay? Now, if you're using a ladder, the further you go up the ladder, what happens to your gravitational potential energy? It increases. In an atom, as an electron, if you go up further from the nucleus, what happens to your energy of the electron? It increases. Okay, so there's a little bit of a ladder analogy here. Now, so there we go. There's our n's. N equals 1, n equals 2, n equals 3, n equals 4, and so on and so forth. For our intents and purposes for this class, we only need to go up through about 4. It'll get everything done that we need to get done. Everyone good on the principal quantum number? This is the one you knew, the one and only thing that you knew. Now we're going to get to the sublevels. Dose. Now, I can't remember what your book uses, although I'm going to go with orbital quantum number. You'll see this in a couple of different... Now, I'll go ahead and look. They might use... Yep. They use a term called angular momentum quantum number. I wouldn't get my panties in a bunch about that. Okay, so anyway, we'll go with orbital quantum number. What this does is indicates the shape of the sublevels. Now, we're going to use different words to represent sublevels. Orbitals is one of them. So I will use the word sublevel and orbital interchangeably. You'll see information at various places that use those two words interchangeably. The orbital quantum number, when we actually start looking at the quantum numbers, is going to be abbreviated with a lowercase l. I like to write it as a script L so that we don't confuse it with 1 or I or anything else. Okay? These are letter-coded. Now, here's the thing. For my regular chemistry class, we are just going to stick with the letter designations. With you guys, I'm going to show you the actual quantum numbers and how they relate to the... We're going to do both, and we're going to do them simultaneously in conjunction. The letters are S, P, D, and F. And we are going to clearly stop there.